it kind of summarizes IP networks. If you have a lot of addresses which all belong to one network, and you are trying to find the smallest network that contains them all. So, for example, if you have those four addresses, when you write them in binary, you're actually trying to find the longest prefix, the longest common prefix of all of them, which is here in red, and the length of the rest, or the length of the prefix, really. So you write it in this way because this is the prefix with zeros at zero padded prefix, and this is its length. So it has 22 bits in common, and those are the bits that form the address 172.168.120, because of course those eight at the end are just zeros. And of course you can do it simply by converting those numbers to binary and doing all those things by yourself. But as I say, Python has a nice battery in the standard library that works with IP addresses, and I have used it mostly to teach people about it. So this is really, this should be two lines, but I tried to make it shorter, so it doesn't distract from the main thing that I'm doing, which is in lines 4 and 5. So what am I doing here? I'm just trying to extract minimum and maximum from the same thing, from the sequence of IPv4 addresses. So if I have IPv4 address of but this is kind of ugly, because I can't really use map, which I would do in this way, because I need two passes. When I need two passes, this first one would just exhaust this map, and this will give me an error because I cannot take max of empty sequence. So I tried to use this map only once, and the very simple way to do it is just use sorted, because when you sort it, you get minimum and maximum, and you get all the others in between, and you can just discard them via this notation. You have, of course, you can say and A will be the first element in the sequence, C will be the last, and B will be the list of all the elements in between. So very long time ago, Python has had this. So you could just extract some first arguments from the sequence. I think probably even in Python 2 you can do it, but I think Python 3.5 has finally enabled you to do this. So you can extract from the start and from the end of sequence. Okay, so I am just extracting the minimum and maximum. Okay, and when I have the minimum and maximum, why do I have them? Because when I XOR them, when I exclusively disjunct them, I will get the common prefix, because of course the minimum will have a 0 at the point of divergence, and the maximum will have 1, and it will differ. So when I XOR them, it will have 1 at that position. So I will, let's say in this case I'm having, for example, those two. So let's say at the point of divergence, of course, minimum must have 0 and maximum must have 1. So when I XOR them, I only get this one, and I get, I don't know what I get, but in this place I get 1. With this is important, and this can be anything. This can be anything, because all I'm interested in this case is just a length of it, because Python has in this library, it has a IPv4 network that has a method Supernet or Supernet, which takes spread. And what is spread? This is just a length of this this part, right? And how do I calculate it? Python has also one nice method on ints, which is a bit length, which is just length in bytes, in bits. So if you take a bit length of this one, it is 10, because it has 8 bits here and 2 bits there. So you just let's say 32, which is, as we all know, 1 and 5 zeros. Length, which is 6. There is one interesting thing here as concerns the tokenizing of Python language. You cannot write this. Why? Because it will give you a syntax error. Why? Because this 32 point is legal syntax. It is just a float, and you cannot follow float with bit length. So the tokenizer just grabs as much as it can, and after it doesn't backtrack. Some people have reported this as a bug, but Guido said that it is an important property for readability, that humans can also read Python without backtracking. So, and it doesn't really harm anything, because you can just put a space in here and it will work. And that's it. You call this Supernet, and the whole preparation was just to get at this spread. When you have how much the addresses are spread, then you just call this function, and it will give you the network. And of course the network is an object, but it has a usable string representation, which is exactly what we want from this. It has a representation of a starting address, or what is it called, gateway address or something like this, and the slash and the length of the prefix. Okay, so this is low level programming of the same thing. You just need to construct all the binary IP addresses. What you do, you take address, you of course iterate through all the addresses in data, you split it on points. Then each part you convert to an integer, and then you convert it to binary, and then you format it with length of 8 and 0 padded, and then you join all of them together, of course. So you just get a string of 32 zeros and ones, and the subnet is starting at 32, and while it has let's say, so len of set is more than 1. That means that there is more than one genuinely different prefix. You subtract 1 from subnet. So you just try to say, in this case subnet is 32, and then you try to form a set with this and this, of course, and all the other in between, and you say you see that the length of this set is 2, which of course means that those are different, so you subtract 1, and you try again, and you try again until you get at this point. Here you see they are different, and then you subtract 1, and they are not different anymore, so you have found your subnet. And when you have found your subnet, then you take the first one. Of course, you take any one, because you cut it at the point of this index, and then you pad it with zeros. So this is ljust, which we know from the hidden word mission. It pads this string to a length of 32, and it pads it with zeros. If you don't give it an argument, it will pad by space. And if you give an argument, then it will pad by what you give it. And then you reconstruct, of course. This is just a binary number, and then you have to do the same thing that you have done in the line 2 in the different directions. So you convert those, cut them, convert them to integers, convert them to string as decimal integers, and you you join those with dots. And you have your router and you have your subnet, and then you just join them with slash. Okay, yes, this is very very bitwise, but of course those two functions are the same as the previous solution, only they are extracted as separate functions. So you can convert string to IP, which in this case IP is just so it is not even a string, it is just an integer in 32 bits, so it is a word in computer architecture parlance, and the function to convert it in the reverse direction. And then you, of course, you map this function, you find your minimum, you find your maximum. Of course, this is what I have written about. If I didn't want to use sorted, I could just use min and max, but then I couldn't have map here. I would have to really comprehend the list. And this is XOR. This is the same algorithm as I do, only it's more low level because it doesn't use this library for working with IP addresses. And this kind of argument is just the same as in previous solution when he tries to find. Oh well, here when you have this diff. Oh, probably this user doesn't know about this bit length method, so he just tries to oh yes, he shifts diff by 1 and shifts subnet by 1 in the different direction until this goes to 0. Of course, it also has this mask, which is nice because oh yes, I see why he does this. It's a bit complicated. When you have this minimal element, it doesn't have to. So here is 1 and here is 0 and here is whatever, and here you have also all 8 of them. But those bits don't have to be zeros. The first one has to be 0, but the other ones you can have 1 here. So you cannot really convert all of them into a network by ending binary bitwise ending with this minimum, because it could have 1 there and it could survive. So you first need to construct this mask. And how do you construct mask? You shift it so you get zeros at the end. Of course, it probably wouldn't if the user knew about this bit length method, then it would probably be written as simply subnet or something like this. So you don't actually need a loop, but you need a loop to calculate bit length if you don't know about the method that does that. Okay, and when you have the mask, you just mask out all those lower bits and you return. And this uses the same formatting, only in the older style with % signs instead of format methods.